Alfred Mohi, an engineer from Switzerland, is seen as the inventor of the turbocharger. At the time of its invention, and today, the turbo's purpose is to take advantage of the exhaust gas produced by the engine. Today, small airplanes and light aircraft are equipped with a turbo to remedy the problem of low air pressure in higher altitudes. Ships and boats also use turbocharged engines, just like most diesel engines of cars do. In a standard 4-stroke diesel engine, air is forced into the cylinder by atmospheric pressure. This is the reason why this kind of engine is known as a naturally aspirated engine. At times of high RPM, for example on the highway, the atmospheric pressure will not push enough air into the cylinder. Consequently, the engine cannot run efficiently. Here, the turbocharger comes into play. A standard turbo, as it is used in boats, airplanes and cars, is composed of a shaft with a turbine wheel on one end and a compressor wheel on the other end. The turbine wheel and the compressor wheel may look the same and are covered by a housing. The exhaust gas produced by the engine enters the turbine housing through the inlet port. At that point, thermal energy is converted into kinetic energy because of the constriction in the turbine. Consequently, the turbine is driven by kinetic energy. As the turbine wheel and compressor wheel share the same shaft, the compressor wheel spins at the same speed as the turbine wheel. Consequently, the compressor wheel draws in air and compresses it. Then, the air passes through the outlet port and supplies the engine with oxygen. Let's have a look at the turbo and other components to have a better idea of the principle at work. The exhaust gas enters the turbine through the inlet port, drives the turbine wheel, and exits the turbine through the outlet port. Hereby, the compressor wheel draws in air, compresses the air and pushes it to the engine. Engines that have a turbo are known as turbocharged engines. A turbo only works efficiently if other components are part of the entire system. We need, for example, an intercooler because the air heats up when it's compressed. So, the intercooler will cool down the hot air coming from the compressor, ensuring that more oxygen reaches the engine. That makes the engine much more efficient. Furthermore, a valve, which is also known as a wastegate, is used to divert exhaust gas away from the turbine when too much exhaust gas is produced by the engine. So, it limits the rotational speed of the turbine wheel and consequently the compressor wheel so that the turbocharger won't be damaged.